This is a question from AQA A-level Chemistry. It is a required practical question from paper 3, and this one is focused on RPA3. Going to recommend, as always, that you pause, have a go at this question for yourself, and then review your answer against the remainder of the video. So I'm going to start off by showing you parts A and B. And then we're going to move on to look at B, part 2 and 3, and part C, a total of 13 marks. Okay, so hopefully you've had a chance to review that. The first set of marks are relatively straightforward. You've simply got to plot a graph. Now, it's easy marks, but only if you take the time to do this with care and diligence. It does tell you to have the volume on the y-axis. That means time must go on the x-axis, so read that question carefully. And then you're choosing a suitable scale. So I've got the scale down at the bottom here, and then I've got my volume going up. I have used just over half of the space. I could arguably have done that twice as high on the volume. But then it comes to plotting those points in. I've got those here, and you're then asked to draw a best fit curve through all of the points. Now that does imply there's no anomalies here, and actually there aren't any. I can see very clearly my curve working through. So estimate the time taken for the reaction to be completed. If you take a look here, we can see that at 90 it's at 560, and at 105 it's at 570. So I know that it's going to stop at some point between those two. I know it has to stop between 105. I know it's still going up at 90. You can actually get here anything between 91 and 105 to get that mark. Okay, let's take a look at B part 1. The volume of carbon dioxide in part A was measured at 293 K, a pressure of 100 kilopascals. Use information from your graph to calculate the maximum amount in moles of carbon dioxide evolved from the zinc carbonate in this 20 centimetre cubed sample. So it is a straightforward ideal gas equation question with a little bit of information gathered from the graph that you've drawn, or indeed from the table above. I'm going to start off, as I do in all of my videos, by actually writing out PV, N, R and T and putting in what we know. That's going to help us direct where we're going to go, what gap do we need to fill, how are we going to do it. It also allows me to check which of these do I need to change? Which do I need to amend? I go through like a checklist. So I can see that pressure, I do need to convert into pascals, and volume, I do need to convert into meters cubed. But temperature is already in Kelvin. R remains as 8.31. Once I've done that, I can take my PV nRT, I can rearrange it to make N the subject, which is what we're interested in, and I can substitute all of those figures in. In terms of showing working out, I am really giving the best opportunity to whoever is marking this to actually see every single step taken. Once I've put those figures in, I can find out that my N value is 0.0234 moles. So let's move on. I'm going to add that at the top again in a second, but we have got 0.0234 moles of gas. Use that answer to calculate the mass of zinc carbonate in the 20 centimetre cubed sample of the calamine lotion. There is an alternative here, but I'm going to work with the correct figures. So 0.0234 moles. Based on the fact there is a 1-to-1 mole ratio that you would need to be able to deduce, that means we have 0.0234 moles of zinc carbonate. I can now use my N is M over MR, rearrange, mass is moles times MR. If I use my periodic table to find the relative molecular mass of zinc carbonate, 1 zinc, 1 carbon, 3 oxygens, it comes to 125.4. Multiply those together and I get a value of 2.93 to maybe 2.94 grams. Part 3. Calculate the difference between your answer to part 2 and the manufacturer's claim that there are 15 grams of zinc carbonate in 100 cm cubed. Express this difference as a percentage of the manufacturer's claim. So let's take a look first of all at the difference. I didn't start with 15 grams, I started with 3. So we do 15 over 5. Because we've got a 1-to-5 ratio. It's 15 in 100 cm cubed. We only had 20 centimetre cubed. There's our 3. And then we are going to find out what the difference is, because if it should have been 3, we actually found our answer was 2.93. So that comes to a value of 0.07. Now I can take that 0.07 and find it as a percentage error of the 3 that we know should have been there. And it comes to a value of 2.33%. Finally, as is often the case in RPA questions in paper 3, we're having to draw a diagram. In this case, we're interested in part A, where we were reacting the calamine lotion with sulfuric acid. So let's start with the conical flask. It's not drawn perfectly, but it would get me the mark. I'm drawing in my bung. That's going to be really important. And cross-sectionally, I can see my delivery tube going through it. I've got that going into a gas syringe and I'm completing that gas syringe drawing. Bear in mind, you could do this by collecting over water. I'll talk more about that in a second. What's really important with this is that you do then go on to label. And I've said there, this is a graduated gas syringe. It needs to specify that it's graduated because we need to know that we can measure specific volumes. I've got my delivery tube labelled, I've got my bung labelled, I've got my conical flask labelled, and I'm putting my calamine lotion and H2SO4 in there as well. The two things we needed to get the 2 marks, the bits that were absolutely essential, were: is it airtight at the point that the gas is being produced and going out of the conical flask? And the second is, have you made clear that it's graduated where we're measuring the volume of gas? So if you had drawn this with an upturned measuring cylinder collecting over water, you would need to draw graduations on that measuring cylinder or label it as a graduated measuring cylinder that would allow you to work out what volume had been collected. That takes us to the end of this question. Thank you for listening and goodbye.